this recording? Hold on. Yes. Okay, sorry. So the shadow problem is quite a bit more complicated than the cone problem because the only thing about the cone problem is that you're doing a is that you just have to put the relation you have to figure out the relation of R and H. And that's the tricky thing here. But with the shadow, it's a lot more tricky because you have the similarity of that you're relating to similar triangles, but also it's just a lot weirder. A lot of weird stuff's going on. But let's just tackle it right here. This is the same. Both of these are the problems from the notes. Um, okay, suppose a 6 feet tall person is 10 feet away from a 10-foot tall lamppost. So it tells us here, but we know that this is 6, this is 10, and then this is also 10 here, but we're going to call this D instead because this value is changing. Oop, that's not the one I'm doing right now. This value is changing, and if we just put it as 10, we won't be able to find the derivative of it. So we know that D is equal to 10, but we're not going to write it down as D, but I'm kind of spoiling a bit there. Anyway, 6 foot tall person is 10 feet away from a 10 feet tall, sorry. The person is moving away at a rate of 3 feet per second. So that means right here, they're going 3 feet per second. Let's draw this out real quick. So I'm going to draw this big triangle here and then this tiny little triangle here. Because these two are related triangles, they are going to have side lengths that are proportional to each other, and it's going to make it a lot easier for us to solve it for one, but also two, that is going to be the equation that we use and take the derivative and all that jazz, the stuff that we usually do. All right, let me draw the big triangle, our huge triangle here. We know that this is D. Oh, wait, sorry. Our huge triangle is all of this, so I already messed that up. This is X, this value here. So we know that for our whole thing, it's going to be D plus X. Because you just have to add those two together. So D plus X at the bottom. And then we know that the lamppost is 10 feet tall. This is going to be 10 feet tall. So we know for that. For the smaller one, distance is X, and our height is. Now we want to identify what this 3 is here and what is changing with it, because we're gonna need to know that later. Um, and if you think about it, the person is moving away from the lamppost at a rate of 3 feet per second. You might think that the X is what's changing here, but it's actually not. The X is the shadow, where the D is the distance between the lamppost and the person. So as he walks away, that distance is getting bigger. I kind of made it more obvious by putting the thing here, but that distance is getting bigger and that D is what's changing. So we know that dd over dx is equal to 3 meters per second? Feet per second. 3 feet per second. All right. Now we can solve by relating these two things. So we know that if we have the proportion of x over 6, we know that that has to be like equal to, because you're using, when you make it a fraction, you're talking about the proportionality of it. So if we had 1 would be equal to 2/4, right? The same type of thing going on here. They're proportional, and that's because they are written in fraction form. That makes it so if you reduced both of these things, they'd be equal. So x over 6, I'm putting this on the bottom and this on the bottom, but I'll let you know, like, sorry, this on the top and this on the top. Let you know that it doesn't actually really matter which way you put it, because there are a lot of different ways to correct. And then d plus x over 10. Okay. Now what we do from here is we cross multiply by multiplying these two together and these two together. So by doing that, we get 60 plus 6x, because it would be like 6 d plus x equals 10x. Why I did that, I distributed real quick. And that's equal to 10x. Then we can take that 6 away and make that 4x, being 6, because those two have the same variable attached. So we can do that. From here, this now is our equation. Like on all the other equations, how we'll have like v equals whatchamacallit. This right here is that equation. All that relation and proportionality stuff we did was just so that we could identify what the equation is. And so now that we have our equation, the next step is to take the derivative of that equation. So what we're going to get here is 6 dd over dx is equal to 4 dx over dt. No, I said over dx, that's dt, sorry. And this is because the derivative of 6d is 6, and you have to add the derivative, and then the derivative of 4x is 4, and you have to add. So this becomes a lot easier when we remember that we identified this earlier. dd, this d is changing at a rate of 3 feet per second. We can plug that 3 in here, equal to 4 dx over dt. 18 over 4, simplify that to 9 over 2. So dx over dt is equal to 9 over 2 feet per second? Yeah, feet per second. This is basically saying that the shadow, which is what we're looking for, is changing at a rate of 9 feet per second, in halves. Because that's what the question is here. What is the length of the shadow changing? Now they ask us at what rate is the tip of the shadow changing? And that is different from this one because in this problem we just found x, but the shadow's tip is also impacted by how far the person is getting away from the lamppost. So the way we do this is we take a look at our big old thing here. We remember from this, we look at this big one because we're looking at the whole thing now and not just this little part to find the length of the shadow is changing because we're looking for the tip of the shadow, the rate of the tip of the shadow. We want to look at our whole big one now. So we know that the height is 10 and the bottom is d plus x. And this is a lot easier because this is our equation right there. We've got it. It's d plus x because that is the relation between these two things that will allow us to find the rate that this whole horizontal line is changing as the person is walking and the shadow is changing. So we can take d plus x and then take the derivative of it, which is just going to be dd over dt dx over dt, because the derivative of d is 1, the derivative of x is 1. That's how we get this. But we already know both of these values from the previous problem. We found that dd over dt is equal to 3, and that dx over dt is equal to 9/2. Now from here, we can just add these two together. You can use a calculator or you can do it by hand. If you do it by hand, that is going to be 6/2 because 6/2 is equivalent to 3 plus 9 over 2 going to be equal to 15 over 2 feet per second. And that is how you solve this. Let me check if I'm right. I'm not giving you false information. Okay, that's right. He didn't answer this, but I'm fairly confident. There you go. That is how you find a shadow, or how you do the shadow problem and how you do a cone problem with related rates.